Howdy, welcome to one of SME Chapter S099's competition presentations. My name is Jonathan Heater, and I will be presenting on behalf of the team for last year's SME Digital Manufacturing Challenge. Our project name was FireBreaker. To introduce the team a little bit, like I said, my name is Jonathan Heater. I am the current president and former project director from last year when this competition was taking place. Zach Norwood, who led our team, was the former president and was hired by Lockheed Martin as an applications engineer. And then Cheyenne is our graduate student at the program, MMET at Texas A&M, and he was excellent at CAD modeling and assisted us with his wealth of knowledge.
Howdy, my name is Sebastian Salazar. I'm the current project director for SME S099, and I assisted with research and design of FireBreaker.
Howdy, my name is Mark Abbey. I'm a newly joined SME member. Last year I joined a meetup with the design team and I haven't looked back since. So we're proud to show you this FireBreaker project today.
To go into the competition summary, teams were asked to design a product that utilized additive manufacturing processes that assisted in sustainable practice and disaster relief/response. FireBreaker tackles on a really big issue that America and the world has been facing with wildfires. Particularly, smoke jumpers are a select group of firefighters that are trained and deployed by parachute to combat these horrible scenarios. Once on the ground, they need to be completely self-sufficient for 48 hours and are typically limited to 100 pounds. Their primary tool is called a Pulaski, which is a combination of a backhoe and a standard firefighter axe, which typically weighs about 14 pounds. Our team wanted to use 3D printing practices to create a lightweight axe/multifunctional tool that provided a much better option for these smoke jumpers with limited carrying capacity. Here, FireBreaker is demonstrated as both being collapsed in a hatchet-like mode and then being fully extended utilizing clips and a 3D printed PEEK interior handle. To give a little bit of the characteristics of the project, the head, so the outer handle and axe head will be made out of titanium with a tensile strength of about 130 KSI, service temp is 600 degrees Fahrenheit, and an overall length of about 12.64 inches. Traditional axes are your forged tool steel, much lower KSI tensile strength. Their service temperature greatly varies, and their length is typically about 14 inches. Limb characteristics, we chose PEEK as our material as it has a really high resistance to high temperatures. It has a tensile strength of 14 KSI, service temp of 338 degrees Fahrenheit, and our overall length for it is 18.5 inches. So to do a summary of our project, the FireBreaker overall weight is approximately 3.8 pounds. Titanium and PEEK are very lightweight material that can both be printed. Traditional axes/Pulaskis are from 7 to 14 pounds. The total length remains virtually the same between the FireBreaker and traditional axe, which then gives the smoke jumpers the leverage needed to do whatever kind of task they're assigned to. Overall cost, we estimated that the FireBreaker would be about $200 just because it is a niche tool that would be using fairly experimental processes. For the upper limb, we have the head and outer handle. Out of titanium material, we would consider using selective laser modeling. And then for PEEK, which is a fairly well-known material, is fused deposition modeling. Thank you for your time and enjoying this presentation. We have all loved and been greatly impacted by SME.